Okay, 2011 B1. So I've read this question a couple of times, and I tried it a couple of times, and something went wrong each time. And from looking at it now, it looks like there's a couple of mistakes in the question. It's causing the problem. So we had a look in this class. We had a look at this in class earlier today. We have our circuit as shown. The resistance here can be adjusted, can be changed, and so the voltage will change and the current will change. And this is the power supply here, two batteries in parallel. So the first part of the question, you are given the voltages, the potential differences, and you're given the current. So here is V, here is I, and you're asked to plot a graph of V against I, which is great, and you can do that. And the reason that that's useful is because we can use one of our EMF equations, that is V equals E minus I or. So if you're plotting V on the Y and I on the X, I should rewrite this as V equals minus or I plus E. So basically Y equals MX plus C. So you can see that the M equals minus or and the C equals E. Or in other words, you can say that the EMF will equal C, and the internal resistance for the power supplied will equal minus M. So that's useful to know. If I go back to the question now, we're asked to draw the graph for 4 marks. So here's the graph here with V on the y-axis and I on the x-axis. And you can do this on graph paper, it's no problem. And the next part is calculate the slope and the intercept. So we can draw our triangle on the graph paper, which I can't do here on the computer, but you draw your triangle and you do the height divided by the base, and this gives you the slope, which we can see here is minus 2.9. The problem is, in the marking scheme, we are told that the answer for the gradient for the slope is minus 0.34, which doesn't match up. But I remember getting minus 0.34 in class earlier today, and that's because I made the same mistake in Excel as whoever wrote this marking scheme did as well. If you look here, in another tab, I have made the same, I've used the same data but swapped them around. So here I put the voltage on the X and the current on the Y, and you can see that the equation I get has a slope of minus 0.339. In the marking scheme, that's what we have there, minus 0.34, in other words, rounded to 2 decimal places. So this is actually wrong because this information comes from this graph, and this graph is wrong for 2 reasons. The first, in the question they said put the voltage on the Y and put the current on the X. It's the first reason. And then the second reason is that our formula V equals E minus I or, you can see that it's already in the form, it's practically in the form Y equals MX plus C from the beginning. You can see that if we have V on the y-axis and if we have I on the x-axis, then the E and the minus or has a straightforward interpretation. If we had it the other way around, if we had I on the y-axis and V on the x-axis, then this interpretation, we can't use it because it wouldn't be true anymore. And in the question, he or she does use that interpretation as well. For the next part, EMF equals 3.12. So they're saying the EMF is the intercept. But we know that this is wrong. It's not 3.12. It's actually 9.18 for the EMF. And the slope is minus 2.9. So the next part of the question, use your values to calculate the internal resistance and the EMF. Well, that's done. EMF is the C and the internal resistance is the minus M. So I'll just write those numbers in from our graph. On our graph, we have C equals 9.18 and minus M would equal 2.94. So that is the internal resistance, and then that is the EMF. Okay, so now we have 14 marks in total. Now the next part, B, we had some trouble with in class as well. Again, the answer didn't match up with the marking scheme. And the problem as well with the marking scheme is that they use a formula. This is the formula I squared R. They have power equals IV, but from Ohm's law, V equals I R. So if you put that in there, you get power equals I squared R. And it looks like that's what they're doing, with the wrong numbers, of course. But if you were to type this in, 8.21 divided by 2 squared divided by 0.68. True, you do get the same number, but it shouldn't be divide here by 0.68. It should be multiply, not divide. So there's a divide here. I'm not sure how that came into it, because you can see it's I squared multiply the total resistance. And the total resistance they have from the previous question here is 0.34, and then the resistance in a single cell is 0.68, which I haven't done yet. So anyways, let's have a look at B now using the correct numbers. So if I go back a moment, this R here is the total resistance for the two internal resistors. And the question, which I haven't completed yet for my 14 marks, is calculate the internal resistance of a single cell. So I haven't done that yet. If I call each of these X, I know that 1 over X plus 1 over X should equal 1 over 2.94. So I get 2 over X equals 1 over 2.94. So in other words, 2.94 times 2, so double 2.94, and we've got it. 2.94 times 2, so 5.88. So here in the marking scheme it says 0.68, double 0.34. That's wrong. It's not double 0.34. It should have been double 2.94. So it should be 5.88. Okay, so we have the X equals 5.88 ohms. Ohms. So that is the resistance in one battery. That is the resistance in, the total internal resistance for the two batteries. That is the EMF for the battery. And so, if I go back now to the question, I have fully answered part 1, 2, 3. I've done the plot, I've got the gradient, I got the y-intercept. Use your values to determine the internal resistance, which I have, and the EMF of a single cell. If the total EMF is 9.18, then the EMF in each cell is still 9.18, because as you should remember that when voltages are in parallel, they should be the same. In other words, when you split a wire, you don't split the voltage, not like the current. Okay, so next we want the power, and it's the power in the variable resistor when the voltage is 0.33, as given in the table above. So when the voltage is 0.33, the current is 8.21. what is the power of the battery. Okay, so what we have here, and then this one here, well, let me draw it in the same direction. Yes, I got it in the same direction. And there's internal resistors here and here. Okay, so we know that the current is 8.21. So that means that the current here is 8.21 amps. So the current going this way is 8.21 amps. These two are the same. So we don't need to use Kirchhoff's rule to know that when the current splits here, it splits equally. So that is 4.1 approximately, or 105. And then here is 4.105. So we know the current in each battery. So we want the power of this battery here. We know the current going into it, 4.105. Do we know the or? Well, we do. We have the or for the battery. This is really our battery here. And this is really our battery here. And the or, I have it from earlier. It is 5.88 and not 0.68. And not divide, it should be multiply as well. So if I go to my calculator now, 5.88 multiply 4.105. I get 24.13, which is by accident nearly, not too far away, this answer here, which is interesting. Accident. Or maybe, no, it is not. I forgot the square. Let me do that again. It is 5.88 multiply 4.105 squared. I forgot to square my current. It's I squared. No, so it's not close. It's quite different. 99. So here it is 99. 4.105 squared multiply 5.88. That is equal to 99. Okay. Let's see what's next. And the last part is suggest why using two cells in parallel might be of benefit compared to using a single cell when connected to an external load. So for the C part here, one way to think about it is if you have your batteries like this, each of these is OR. The total is 1 over OR plus 1 over OR, which is 2 over OR. But if you have your batteries lined up to make sort of one large battery, the resistance internally adds, so it'll be OR plus OR, which is 2 OR. That's actually 4 times bigger. So the benefit of parallel is that you reduce the internal resistance. You keep it smaller by keeping the batteries, by putting the batteries in parallel instead of in series. Okay, so I think the problem with this question in class, there were basically 3 problems with it, I think. The first problem was here, that they asked for the right graph, but they calculated the values wrongly, because in Excel they had their V and the I the wrong way around. So that was one problem. Well, I think there was only two problems really. That was one problem. And in part 3, the wrong numbers were used, of course, in the previous part as well. But also, even though the right formula was used here, again, some calculation problem here. A divide by or came into the question instead of multiply the or. So I don't know what happened with this question, but there's at least two problems, which means that we can never get the answer to match up with the marking scheme, because it would seem that the marking scheme is wrong on this occasion. If you think I've made a mistake somewhere, let me know. But I think it's pretty clear that there's at least a mistake with the first part here. The y-intercept is 3.12, and you can see that the only way to get the y-intercept as 3.12 is if you use this graph that puts v on the x-axis. Let's check that that's right. Well, if v is 8.21, I should be 0.33, so if it's 8.21, it's 0.33, so that is right. So if you use this one, you get what's in the marking scheme, but you're not supposed to use this one. You're supposed to use this one with v on the y-axis, like they said, and I on the x-axis, like they said, and you can see that the c is different, quite different, 9.18 versus 3.11. So it means our answers are going to be way off. So the problem was with the question.